So hello and welcome to dynamic programming. These are all common questions that will coming in your interviews in any interview, whether startup or service or product based companies who are going. Dynamic programming are compulsory questions in any DSA round. Okay, first or second round. Okay, both in first and second round will be asked. Okay, now let's solve some problems over here. So the first problem that I see is the house robber problem. So the house problem is as such, like you are a house robber who can't rob two. So there are houses in order. Okay, 1 2 3 4 5 7 8 9 10 houses or many houses. So you can't rob two adjacent houses. You can rob only non-adjacent houses, and you have to at the end you have to find out what is the maximum amount you can steal by robbing two adjacent houses. Okay, that's the so you are a house robber who can't rob two adjacent houses. Find the maximum amount that you can steal. Okay, so the constant questions are: what if there are no houses to rob? If there are no houses to rob, obviously you can't make any money, so you have to return 0. Do you have to steal the two consecutive non-adjacent house? Only two consecutive non-adjacent house? No. You can that is house at position number 1 and 3 like this. Two consecutive non-adjacent, no. So consecutive non-adjacent means, okay, consecutive non-adjacent means that you see, if house number first house has the amount 1, should I so 5 I can't obviously steal. This house number 2 I can't steal. House number 3, should I only steal house number 0 and house number 2 here? Can't I steal other houses? You can steal any other houses. Only thing is that it shouldn't be adjacent house, like house number 1 and 5 or 5 3 3 0 0 9 9 4 like this. You can't. So the next house you can't basically steal. You can steal any other house than the next house. Okay, that's the meaning of non-consecutive. So basically understanding the concept is very important. Okay, that is house at position number. Okay, answer is no, we can steal from any house which are non-adjacent. Okay, can you have multiple solution? Yes, you can have multiple solution. You can have any way of solving this problem, right? Multiple solution you can have. Okay, can a house have no money? Yes, a house can have no money. So in that case you have written 0 from there. Can a house have negative money? No, and a house should have money. Okay, it can't have negative money. These are the constraint. Okay, now how to know that this is a dynamic? Basically this constraint you have to ask your interviewer, or you have to assume that it will be mentioned in the question. Okay, if you go to Leetcode, it will be mentioned, the constraint. Okay, how to know that this is a dynamic programming question? This is important. How to know that this is a dynamic programming question? Okay, this is important because here I'm trying to figure out what is the maximum, what is the minimum. So these words you have to know, that minimum, maximum. Whenever this word is written, it means that you are trying to find the look, like I've written over here, min, max, optimization. These are all optimization problems that have a lot of solutions, and we are asked to pick one of the solution. They are usually dynamic programming question. Basically what it is trying to say is wherever mean or max words are there, minimum subsequence, maximum output, these words whenever is there, it means that they are asking you to memorize it. Okay, basically you have to memorize, because you can use recursion to solve this kind of problem, or you can because recursion also consumes a lot of memory, right? So you have to use memorization to solve these problems. So wherever these words minimum, maximum are there, you have to always use dynamic programming. Okay, you have to know that these are dynamic programming questions because you are optimizing the solution. Okay, now recursion linked to dynamic programming. Yes, we know recursive is related to dynamic programming. The recursive function is that we have to find obviously the base cases first, and after finding the base cases you have to solve it. Okay, the recursive function you can do it. Okay, now so what is the recurrence relation? The recurrence relation is, first we determine our base case, and next recursive call arguments we have to do. Okay, okay, so now let's discuss what is the recurrence relation over here. First we determine our base case, and next recursive call arguments. Okay, now let's discuss. So you see I'm having these 1 2 3 4 5 6 houses are there. So index number 0 to index number 5. Okay, so first house has the amount 1, then has amount 5, then 3 or 0 or 9 and 4. Okay, the amount 0 is also there in any house. Okay, now we can check either from right to left. We can go from right to left, or we can go from left to right. anything, but think that you are going from left to right. Okay, I prefer to generally go from left to right. Okay, now the option 1 is steal the current house. If you are stealing the current house, for example, you are stealing 3, or maybe let's steal 9, so index number 4. Okay, because there are 6. Okay, index number 5, 4, correct. So if I'm stealing 9, then I can't steal 0, right? I have to steal, I would have stole 3, because I minus 2 only you can steal. So adjacent we can't steal, right? If I decide to steal 9, I can steal only 3, or the maximum till I minus 2, right? What is the maximum value that I can steal till I minus 2? Okay. If I don't decide to steal, so because if I steal it, then I will I'll consider 9 as the amount that I have stole, and the maximum amount till I minus 2, because till I minus 2 only I could have steal. Okay. Now second is, if I don't want to steal at position number I, here in this case the value 9, in that case till I minus 1, that means still 4 here till 0, what is the maximum amount? That will be the amount I would have stolen. Okay, because in this case, because I'm not stealing here, so I can check till I minus 1, right? So that is what I've written. Option 1, steal current house. If I steal, let's steal house number 5, that is 9. So I equals to 4. Okay, we can't steal house I plus 1 or I minus 1. So I plus 1 is 4, we can't steal. I minus 1, 0, we can't steal. Okay, but we can add the amount if we have stole any house till I minus 2. So till I minus 2, that means till this I minus 2, that is 0, 1, 2. Till 2, whatever is the maximum amount that I would have stole, that I can add it. Okay. Or can steal I plus 2 house if it's okay. If there is I plus 2, that means there is, so if I'm stealing here, if there is I plus 2 is not there, right? So I can't steal. If it is there, then I could have told that also. That means till I minus 2, what is the maximum amount that I could steal, or if there is I plus 2, that also I could steal. And that is first option. The first option is if I decide to steal. Now second option is, if I don't decide to steal from current house, if I don't decide to steal from current house, then find the maximum amount till I minus 1. That is what I'm saying. If I don't decide to steal this house, so till I minus 1, whatever maximum amount I could have stole, that is the maximum amount that I could have stolen. So there are basically 2. So one is I stolen house. If I'm stealing the house, then current house amount, that is 9, plus this maximum amount till I minus. That means I'm doing a recursion here. Still I minus 2 I am again calling, so that I'll find the maximum amount till I minus 2 that I would have stored. Okay. Or if I don't steal it, then still I minus 1, that means I'm till I minus 1 till 0, I am getting the maximum amount that I might have stored. Okay. There is 2 options. Now after getting the 2 options, 2 ways in which you are calculating the maximum that I stored, just find a math.max will do, and then find the whatever is the maximum amount of both these options, that will be the maximum amount that I'll be stealing if I am the robber. Okay, that is the solution basically. Okay, this is our recurrence relation, and when this will stop when I is 0, because return amount in the house. Obviously when I is 0, there is there is nothing more to go down, because it will be a kind of a tree like structure, right? So steal of I minus 1, like the steal of 3, steal of 2, steal of 1, like this recursion will happen, right? So still I is 0, because after I is 0, there won't be any house, so we have to return. If I equals to 1, then find the maximum amount between the 0th house and the first house. That means between the 2 houses, whatever the maximum, that is the maximum amount we can buy. Okay, so this is the condition when the recursion will stop. Now if you think about the brute force solution over here, it can be something like this. I call the house robber function, I pass the houses, find the length of the houses. Okay, what the length, then return steal of houses at n minus 1. That means basically I am having one more function where I am passing all the houses, that means the array which has the amount of each house, right? And then the length of the array I am passing. So here what I am doing, if I is 0, that means if there is no houses, then I return 0, because I don't have anything to steal. Now if I is 1, that means if I am having only one house, sorry, I is 1, sorry, this is I, not n. So if I equals to 0, I think this is not the correct. If I is 0 means there is one house, right? So I have to return here the house of 0 I have to return, okay, not return 0. If n is 0, then yeah, this would be if n is 0. So if n is 0, n means the length that we are passing. Oh, I refers to the n minus 1, that is correct, okay, then it is I only. So if length is 0, okay, then return 0 because there is nothing. If length is 1, that means there is I think there is one more thing that I have to add. Okay, so here I is 1 means, so suppose think that there are two houses, then I have to, if there are no houses, return 0. So if there are two houses, find the maximum out of both the houses that we can steal. I will steal that house from where I'll get the maximum amount that I can steal, right? So basically we'll find the max of house number 0 and max and house number 1, simple. Okay, but from I is 2 onwards, from the third house onwards, we have to put our algorithm. If I decide to steal the house, I take the amount of the current house plus the amount, the maximum amount till I minus 2. Okay. If I decide not to steal the house, then I will find out the maximum till I minus 1, and then finally I will be returning the maximum out of both these solutions. Okay, and this will give me the result. Okay, now this will be n to the power 2 time complexity, because we will be dealing with the array will be called twice. That's the reason n to the power 2. How to make it big of n? How to make it? We don't have to we don't have to do steal 2 again if it's done. Yeah, that is what I'm saying. So if I have done steal of 2 earlier, I don't have to do it, right? That means I have to save the particular value. Here comes memoization. So basically what it is trying to say here is that if this will be steal of 2 or steal of 3, steal of 4, like this is there, right? Because we will be going from I minus 1, I minus 2, I minus 2 or I minus 1 will be handling. So still, if I have done a calculation earlier for that particular value of I will save that value in a array or an object. Okay, and whenever the need comes that I need to find the value of steal of I again, or steal of 1 or steal of 2 or steal of 3 again, then I will use that memoized value. Okay, in that case I don't have to do this operation again. So big of n to the power 2, the n square will be coming to n in that case. Okay, that is what I have written over here. So I take the array, a normal array, and I'll pass that array. Now if I just write if array of I is valid, that means if the solution is the solution is already present in memoized format, I will return the value. If it is not there, then I will do the calculation over here. Okay, so that is how we solve this. So here if you see, if it is not there, then I have to find this same thing I will do. I'll just do an array of I equals to maximum amount, and maximum amount I'll store in array of I and then return array of I. Why we are doing like this? Because when I do like this, in the next case, whenever I'll be looping, then I will be checking if array of I is there or not. If it is there, then I don't have to do the check again. Nah? That's the reason we are storing in array of I. Okay. Now the pseudocode is something like this. Okay, these are the different values. Okay, so these are the different values that is there. These are different amount in the houses. House numbers, the first house number 0 has value 1, house number 1 has value 5, house number 2 has value 3. So the different houses, 6 houses are there. These are the values, the amount that is there in each house. Now, so if I have only one house, that is 1, I will return 1. For house number 2, I will check the maximum amount between house number 0 and house number 1, that is 5 over here. So I'll return here 5. House number 3, now there are 3 options, so 1, 5 and 3. So if I decide to buy house number 3, the maximum can be 3 plus maximum amount of I minus 2, that is 1, that means 3 plus 1, 4 I can get. Or if I don't decide to buy, from 0 to I minus 1, what is the maximum amount? That is 5. So now I have 2 options. One is 4 I am getting by calculating 1 and 3, adding 1 and 3. Or I am getting 5 here. So what I will choose, what is the maximum amount of both these options? That is 5. So the answer is 5. Now when this is moving over here to 0, if I decide to buy 0, then what is the maximum amount? So it will be 0 plus the maximum amount till I minus 2. Between 1 and 5, what is the maximum amount? It is 5. So that will be 0 plus 5, it is 5. Or if I don't buy it from till I minus 1, that is till this, what is the maximum amount? Is 5. So it is written 5. So I am having one is 0 plus 5. One is having only 5. So in either case, maximum amount is 5. So the written is 5. So like this, you have to calculate. Okay. So these are the maximum amount that I will be, getting if I try to buy try to steal non-adjacent houses. Okay, the maximum amount that will be getting in over here. Okay, the pseudocode says that, okay, same thing that I've written above. So n is 0. If it is, there is no house, written 0. Okay, and array of 0, yeah, obviously array of 0 will be house of 0. So if there is one house, there is that I'm putting in the base array of 0. In the loop, what I will do, if I is 1, that means for the first, so I is 1 means there are two houses. In that case, just find the maximum between the house number 0 and house number 1. So that is array of 1 it becomes. Okay, then that means here the maximum value array, this is the array, right? Then that is what I've explained above right now, right? Now else, stolen house, if you are stealing it, take the current value plus array of I minus 2, that is if it is there. Okay, array of I minus 2 if it is there, or if till array of I minus 1 if it is there. Okay, and array of I will be maximum. So the final value is maximum of, if I am stealing, so the maximum of these two options. Okay, so this is the this is, and then finally I will be returning the array. Okay, that is the explanation that I gave. It's the video is very long, so right now what we'll do is that we will move to the solution part. Okay, so now let's have the function. So function is steal, or maybe I'll just study a rob, because we are robbing it. And to this function, what I'll be passing is the array, all the houses array. Okay, I'll just write here nums. Okay, I'll just write here let n equals to nums dot length. Okay, if length is if it is 0, that means there are no houses, then return what I'll return is 0, right? If it is 1, that means there is one house, then I'll return what? Nums of 0, right? The first house value I will be returning, I mean, because there is only one house that I'll be returning. Okay, now let's take a base array, so where the total amount will be there. Okay, so let it be a simple array. I'll just write here let. Okay, now what I'll do, so array of so now let me comment base will do. Okay, so array of 0 will be the first. So if there is one house, then array, the total value or the maximum amount that I can steal is, I can rob is that what is the value that is there in the house, right? So in that case, I'll just write here nums of 0. Okay, if there is one house, right? Because from there here we can know if there is one house or not. Okay, and if there is two houses, basically we are setting the base here. If there is two houses, then what is the maximum that I can have? Because here I am doing a memoization over here. Okay, so that means I am remembering the maximum value at I is I of 0. So I'm remembering the maximum value at each if I decide to rob at that particular house, right? So for the first house, I'll be for array of 0 will be math dot maximum of what? Nums of 0, because the maximum amount between the house number 0 and house number 1, right? So now our base is ready. Okay, Then now from, let I equals to 2, from 2 will start, and I less than n minus 1, okay, and I plus plus. So now what we'll do, so here array of I will be, okay, so array of I will be, what it will be? It will be, you have to find the maximum between two options, right? So if I buy it, that means it will be either, so I'll take nums of I will take, okay, plus array of I minus 1, sorry, I minus 2, because till second, till I minus 2, what is the maximum amount of money I can steal, that I will do, or till I minus 1, what is the maximum amount. Now why we are doing like this, why you are not using recursion? Because recursion makes the time and space complexity big of n square, okay. So to make big of n, we are using this memoization method. So basically here I am memoizing, so setting up the base case, and here I will be, because if it is 3, then I am having 0 and 1, right? So if it is so from 2, 3, 4 onwards, I will be having the values, memoized values, so I don't need to do a recursion again, okay. So this is the maximum amount, and that will be for each position or for each house, what is the maximum amount I can steal till that house, okay, whether I decide to buy it or not, okay. Now at the end, what we'll do, we'll just return it. Now, there is one more way without using memoization or recursion also you can do. I'll show you after this. Let's return this first. So return array of I, okay. Okay, so one mistake I did. So array of I, not this won't be array of I. The maximum value will be at the end, right? Because at the end only we'll know what is the maximum amount we would have stolen, right? So like our maximum amount is there at the end, right? Okay. So similarly, our maximum amount will be found at the end. That means length of the particular array, that is n minus 1. Okay. So this is the maximum, this is the last index of the array. And this won't be also the n, that means it won't be the initial array, it will be the length of this array, okay. So it will be array dot length minus 1, okay. This is our answer. So basically we just need to call Rob, and we have to pass the value. So let's pass the same result. So if I'm passing 153094, I should be getting 14, okay, 153094. Let's pass 153094. So 153094, okay. So let's run it. So I've added the log over here. We'll do nodescript.js. Yeah, CC answer is 14, okay. Okay, so everything's working perfectly. So this is the solution. First, let me do a recall again. So I'm having the Rob function, I'm passing the array. If I see there is no houses, then I'm returning 0. If there is one house, then I'm returning the first, that house amount only, because that is the maximum I can steal. If there are two houses, then I find, so the base house, the initial house will be array of 0, that is the maximum amount for array of 0 for one house. For two houses, I find the maximum between house number 0 and house number 1. And I save it at array of 1, because this is needed to for memoization, to store the values, to store the maximum amount that I can steal at each house, okay. Then so similarly for every house, I'm storing till that house what is the maximum amount I can steal. So if I steal that house, I add that value, as well as till house I minus 2, what is the maximum value, that I would have already done it because I am doing it here. So that I will value, or the till I minus 1, if I don't want to steal it, till I minus 1, what is the maximum amount. Out of these two options, I find the maximum, and I have it in the array of I. Why in the array of I? So array of 0, array of 3 will be the maximum amount till I is 2 or I is 3 or I is 4, like that it is there. And finally at the end, when I find the all the
item, I mean the maximum amount that will be found at the end, that I'll be returning. So here is the solution for this DSA questions of house number. Hope you like this video, and yeah, let's move to the next video.